this particular session, we will start with the examples of the degrees of freedoms example or degrees of freedom. How we can write it for different kinds of systems. So for ice, water vapor and water system, we can write F is equal to 0. There is no degrees of freedom is allowed here. That means capital F is equal to 0. Now, next one is water and water vapor. There, capital F is equal to 1. So the variable, or I should say the degrees of freedom allowed is 1. Likewise, what we will have here is pure gas system. A system which contains pure gas is basically F is equal to 2. It has degrees of freedom 2. And third one is mixtures of gases. Capital F is equal to 3. So here you can have 3 different degrees of freedom which is allowed for you to change. Let's begin with the new point, which is a one component system. Here we will take a look at a water system. So first let's understand that what is a one component system. Here for one component system we can write the phase rule equation as capital F is equal to C minus P plus 2. Now, let's put the value of component here. So, as we have only and only one component, we can write 1 minus P plus 2. So, we can write capital F is equal to 3 minus P. This is how we can calculate the degrees of freedom for our one component system. Right? Now, at the point where all the 3 phases, that is solid, liquid and vapor, are in equilibrium with each other, it is referred as the triple point. Okay? Remember it properly because this will came into water system also. Now, let's take the first system, which is the water system. Under the normal conditions, the system water is a 3-phase, one component system. Which 3 phases are involved here? So here we will have a liquid water, we have ice and we have water vapor. All the 3 systems are in contact with each other or are in equilibrium with each other. Now, all the 3 phases can be represented by one chemical species, one chemical entity, which is H2O, and because of it, it is known as one component system. Okay? In this manner it becomes one component, 3-phase system. Right? Now let's take a look at the phase diagram of water system. We can draw a phase diagram using 2 different axes. We have pressure on one axis while we have temperature on another axis. Here the units which are taken is temperatures, unit is Celsius, and for pressure we will take atmosphere. So as you can see it here, what we have is, we have a 4.68. As you can see, different values are there, different points are there, as well as the curves can be also observed here. Right? And even one point is there. So as you can see in the image, as we raise the temperature from 0, as you can see, this is 0 here, right? So this is the freezing point at the 1 atm and 0 degrees Celsius. After that, we have 0.0078 temperature. There the triple point occurs. That means all the 3 phases are in equilibrium with each other. Then we have 100 degrees. That is boiling point of the water. That means at that particular point, our water will convert itself into vapor. That means it converts itself from liquid to vapor. Right? Now as you can see, 3 different phases are there. Number 1, ice. Number 2, water. Number 3, water vapor. Okay? Different curves are there. First curve is the sublimation curve. Right? Sublimation curve shows that how the ice can directly get converted into gas or vapor form. That is known as sublimation curve. Then we have ice to water. That ice to water is melting curve. Right? Then we have water to water vapor, which is known as vapor pressure curve. Here we have one point which is O. This O is a triple point. Then we have supercooling curve. That means after the triple point occurs, if we drop the temperature at a particular point, we get a supercooled condition. So, here what we will have, the silent features of this water system can be divided into three different parts. Number 1, curves. Number 2, areas. Number 3, points. Which are the curves which are possible here? So here, the curves which can be possible are OA, OB and OC. Three different curves are there, OA, OB and OC. The triple point which can be possible here is 0 or O, right? So at that particular point, the degrees of freedom become 0. How? So at that point, all the three phases are coexist with each other, has one component. So let's put all the values into F is equal to C minus P plus 2. Here the value of C is number of component 1, the value of P becomes 3. So let's put the value 1 minus 3 plus 2, it becomes 0. So the degrees of freedom becomes 0. So as soon as you change any particular kind of condition, the change occurs. This is how the triple point happens. Now, let's go to the third one, which is the areas. Which three different areas can be possible? So we have area AOC, we have area AOB, and we have area BOC. At that particular point, if we want to consider or calculate capital F, we can calculate it as capital F is equal to C minus P plus 2. Let's put the values for it. 1 minus 1 plus 2 becomes 2. That means the degrees of freedom becomes 2. Right? Another fourth feature which can be observed is metastable system or supercooled condition which can be observed in water system. Right? So let's see that how it is possible. Let's go to all the features one by one. First one, let's take a look at curves. First one is curve OA. It is known as the vapor pressure curve of the water. Okay? Now, it represents the vapor pressure of the liquid water at different temperatures. The two different phases of water and water vapor coexist in equilibrium along this particular curve. Now, when the vapor pressure is equal to the 1 atmosphere, the corresponding indicated on the phase diagram is the boiling point, which is 100 degrees Celsius of water. Right? Curve OA terminates at A when the liquid and water are indistinguishable from each other and there is left one phase only. So it cuts at that particular point and after that another phase starts forming. This is the way how we can understand it. Right? Now, second curve is curve OB, which is sublimation curve of ice. It shows the vapor pressure of solid ice at different temperatures. The two phases, solid ice and water vapor, coexist in equilibrium along with this curve. As you know that sublimation is conversion from solid to gas directly. Third curve is curve OC, the fusion curve of ice. It depicts the effect of pressure on the melting point of ice. Since ice melts with decrease in volume by Le Chatelier's principle, the melting point is lowered by an increase of pressure. So along the curve OA, OB and OC, there are two phases in equilibrium with each other. For an example, here we have taken OC, right? So for OC, we know that two different phases are in contact or in equilibrium with each other, right? So we can write the degrees of freedom as capital F is equal to C minus P plus 2. How many number of components can be possible? 1. Number of phases possible? 2. Let's put the value. 1 minus 2 plus 2 is equal to 1. So the degrees of freedom allowed is 1. Right? In this manner we can calculate it for each and every kind of different features. Here we have taken a look at curve. Next we will see in our next session. Thank you so much everyone.